Today we're reviewing graphing quadratic functions. So remember, with quadratic functions, standard form is y equals ax squared plus bx plus c. So a is always the number with x squared, b is the number with x, and c is just the number by itself. When you're trying to find the axis of symmetry, you do the equation x equals negative b over 2a. So if you were to come down on question 25 and do that, find the axis of symmetry. We call it AOS just for short. First thing you have to do is find out what A is, find out what B is, and find out what C is. Again, A is always the number in front of x squared, so 1. B is the number in front of x, so negative 6. And C is the number by itself, the constant. And then you're going to plug that into x equals negative b over 2a. X equals negative b. B is already negative in this one, so a negative and a negative, we get a positive 6 over 2a is 1. So that means x will equal 3. So that's where your vertex is going to be at. It's going to be at 3. So your vertex is going to be the very middle of your parabola. So that's why I'm putting it in the middle of my table. To find the y, I'm going to go back up to this equation. And anytime I see an x, I'm going to plug in 3. So to find y, I'm plugging in 3 for x. And then we're just going to put that in a calculator. So 3 squared minus 6 times another x, so I'm plugging in 3 plus 8. I plugged all that in a calculator and I got negative 1. So 3, negative 1 is my vertex. 3, negative 1 is my vertex. That is the algebraic way to find your vertex, and that's what the second half of your Delta Math assignment is asking for. But then I also want you to know how to graph it. So under Desmos, I'm going to go to test practice because this is what you'll be allowed to use on your EOC. And we're going to choose our EOC, which is the South Carolina Standard Assessment. And I'm going to be graphing. So I'm going to hit the graphing and then start practice. So when I graph it, x squared minus 6x plus 8. There's our graph, and you can see your vertex is right here, 3, negative 8. So even though it says to do it algebraically, if this was the EOC, you can do it algebraically and then check your answer and make sure you get it right. 3, negative 1. Now, from the video, the next video I posted, you can get a table of values to fill out without having to keep plugging in numbers. So, but instead of y, you have to label this f of x. This we also have to change to f of x. This is x1. And I want 3 to be in my middle. So I'm going to start at 0. 1, 2, 3 is the middle. 4, 5, 6. And you can plug in any number you want. See, 7, 8, 9, 10. This goes on forever. The table gave me 7 points, so I'm going to graph 7 points. So 0, 8, 1, 3, 8, 3, 2, 0. And it's just this easy. Just fill out your table. Your calculator does it for you. 4, 0, 5, 3. And see, it's symmetrical. So once you get your vertex, it's symmetrical. So negative 1, 0, 3, 8, 0, 3, 8. So that was my vertex. 3, negative 1. So then I have 2, 0, 4, 0, 0, 8, 10, 9, 8, 1, 3. And there is your parabola. X squared, since it has a squared exponent, That makes it this parabola shape. And then we're filling out all this information. Parabolas, quadratic equations, always have all real numbers. Your x values for your domain is all real numbers. And that's because it does not matter what x value I choose to plug in. If on the EOC, you can see it written as negative infinity to positive infinity, just to get used to seeing both. So your range is your y values. Unlike x goes on forever to the left and forever to the right. Range is up and down, but there aren't points down here. Our first y value is right there. So start at the bottom, work your way to the top for range, bottom to top. So our first y value is at -1, and then it's above that. So I'm going to take my y value greater than -1 or equal to, because there is a point at -1. Or another way to write that is starting at -1 with a bracket, because that's including, and going up forever to infinity. We'll have a whole lesson on range and domain again, so don't worry about that too much, but we have to know it before the EOC. So with range, you start at the bottom and go to the top. For a domain, you start on the left and you work your way to the right. So if I was going to do my domain, starting on the left, the first thing I get to on the left is an arrow headed to the left forever, which is negative infinity. And I keep going my graph, I get to an arrow headed right, positive infinity. Then my y values starting at the bottom. There's no y values until I get to -1, and I go to the top, and the top's going to positive infinity. Again, we're going to work on domain and range again, but that's just a quick summary. Our axis of symmetry is always the vertical line going through your vertex. Vertical line going through your vertex, where it's symmetrical. You see a butterfly, it's like this half and this half is symmetrical. You've been doing that since elementary school. What's different is writing it as an equation. So x equals, and then it's the x it goes through. 1, 2, 3. And that will always be the x of your vertex. See, this is your axis of symmetry. We already solved for it. Our vertex, we found 3, -1. Visually, if this graph is opening up, which it is, it's going to be a minimum. So if your graph opens up, your vertex is going to be a minimum at the very bottom point. If your graph opens down, it's going to be a maximum at the very top point. So if you're looking at a graph, trying to find your maximum or minimum, look visually for it. X-intercepts are where you cross or touch the x-axis. So right here and here. And they're written as points. So 1, 2, I went right 2 and up and down 0. I went right 4 and up and down 0. If you notice the pattern, y will always be 0, and you'll have to figure out what number it is. Y will always be 0, and you have to figure out what number x is. With the y-axis, it's opposite. X is 0, and you have to figure out what y is. How I remember which order it is if I'm trying to find the x-intercept, you're solving for x. So x will be the number, y will be 0. If I'm trying to find the y-intercept, I'm solving for y. Y will be the number, x will be 0. And in this case, it's 0, 8. I went up, left and right 0, and I went up 8. So that's standard form. The other form of quadratics is vertex form. And vertex form has x in parentheses being squared with a number being added or subtracted to it, and a number on the outside being added or subtracted to it. I'm sorry, I messed up. This is supposed to be minus h. So if you come down here to question 28 on your review, this is vertex form because x is in parentheses being squared. Instead of a, b, c, now we have a, h, and k. A A is the number in front of the X, in front of the parentheses, so ours is -1. H is the number inside the parentheses, but it's the opposite of that. Anytime you come out of parentheses, you change the sign. So it's actually not 4, it's -4. And K is 9. If you're trying to find the axis of symmetry, vertex form is the easiest because it's just X equals H. And we already found that. So X equals -4. And then your vertex. This is called vertex form because it's easy to look at the equation and see the vertex. H is -4, K is +9. So -4, +9. 1, 2, 3, 4, +9. 1, 2, 3, 4. Okay. And then your line of symmetry goes through that always. So when I go to graph it in Desmos, I want -4 to be my middle number because that's my vertex. And then I want 3 to the left, 3 numbers smaller than it, and 3 numbers bigger than it. And since it asks for my y-intercept, I also want to plug in 0. So I'm going to start at -7 and go to 0 when I graph it. So I'm going to graph it negative parentheses x plus 4 squared minus 9. So these points still work. You can zoom out and see. Like I can use any points for x, but it's not near my vertex. So if I was just to graph these points, it would look like a line. So that's why we don't want to graph any points. We want to graph points around your vertex. So like I said, I'm going to start at -7. I'm just going to change these to -7. X. I have a million points. I don't need to graph all of them, but so 0, 5, 8, 9, 8, 5, 0, 0, 5, 8, 9, 0, 5, 8, 9, 8, 5, 0, 0, -7. So I already have my vertex, -4, 9, and then -5, 8. And it's symmetric to this line, so 1 to my line of symmetry, 1 to the other side. -6, 5. 1, 2, 3, 4, 5. 2 to my line of symmetry, 2 to the other side. -7, 0. 3, 4, 5, 6, 7. 3 to my line of symmetry, 1, 2, 3 to the other side. And 0, -7. 1, 2, 3, 4 to my line of symmetry, 1, 2, 3, 4 to the other side. So there's your perfect parabola. Domain for all quadratics is all real numbers, or written -infinity to +infinity. Range is your y values. Start at the bottom and work your way up. Starting at the bottom, this graph is going down forever, -infinity. And then working my way up, the last y value is right here at 9. So -infinity to 9. Or if you like inequalities, your y's just have to be less than or equal to 9. X-intercepts, where you cross or touch the x-axis. -1, 0, 7, 0, -7, 0. And y-intercept, 0, -7. Okay, I'm trying to keep this video short, so those are the only two I'm going to do. If you have any questions, let me know and I can do more. So your assignment is Delta Math, and I want to remind you, pause it here if you need to, but vertex, it's always one coordinate, x, y. Axis to symmetry, it's one equation, x equals your number. Your roots and your x-intercept are the same thing, so don't let roots fool you, it's still the same thing. And then your y-intercept is one coordinate. So hopefully that helps you in your first assignment. And then your second part of it is asking to find the vertex algebraically. And that, remember, you have to start with your axis of symmetry and then do your vertex. So first thing you find is A, B, and C. A is the number in front of x squared, 1. B is the number in front of x. There isn't one, so it'll be 0. C is the number by itself. There isn't one, so it's 0. And then you plug that in. B is 0, so negative 0 over 2 times 1 is just 0. So your vertex is x, y. So my x I got was 0, and I plug 0 into my equation to figure out what y is. So plug in 0, and 0 squared is 0. Or graph it. You have Desmos, really shouldn't take that long. Where is my Desmos? Graph it right here. 0 x squared. That's your parent function for quadratic. So hopefully you know the vertex is 0, 0. Do one that has a little bit more numbers. A is the number in front of x squared. B is the number in front of x. C is the number, the constant by itself. X equals, I'm plugging in a negative 6 to a negative b, so it's going to make it a positive 6. Put that in a calculator. 6 divided by negative 2 is negative 3. So that's the x of your vertex, negative 3, and you have to solve for the y. Try to write it out once every time. So y equals negative 3 squared minus 6 times negative 3 minus 2. Put that all in the calculator. Or graph it. X squared, negative x squared, minus 6x minus 2. Or you found out it was negative 3, 7. Negative 3, 7. Or you can see your scientific calculator. So that is how you do that. Plugged it in, you got 7, so 7 is my answer. All right, again, let me know if you have questions. That is your quadratic review on graphing.